This lesson right here, 8-5, linear, exponential, and quadratic models. We need to recognize the big thing. Okay, what makes it exponential? What makes it linear? What makes it quadratic? Let's check it out. JC and Emma use different functions to model the value of a bike X years after it's purchased. Here's JC's function. Here's Emma's function. And here is a table, okay? For part A, make sense and persevere. Why did JC and Emma not choose a quadratic function to model this data? Because notice, we're talking about money and an amount that goes down. Here's the thing. The reason why we're not doing quadratic is because we have a starting value and it goes automatically down right off the bat. So quadratic would not work, okay? But notice this, it's gotta be consistently going down. Notice how this is going down by 15, then by 13, then by 11, then by 9. Linear is not going to work because it's got to be consistently it's got to have a constant slope. So therefore, Emma's function will work, essentially. We need to determine how we can figure this out, okay? If it's being subtracted or added by the same number, this is considered to be linear. Notice how they're being all added by 2 to get to the next number. Boom, linear, okay? But if it's not linear, then we have to check to see if it's quadratic. And what we do is we take our differences that we found. So notice how this was 6, this was 10. And if it's consistent, it's quadratic. Okay? However, what if it's exponential? Okay, well, linear is not going to work. Quadratic's not going to work. We then divide the groups of numbers. If it gives you the same answer, it's going to be an exponential function. Okay? Let's take a look at this. Okay? So from here to here, it's going to be -3. From here to here, -9. From here to here, -15. Okay? Does not look like it's linear. So now let's check and see if it's quadratic. Okay? -9 minus -3, that's going to be -6. Okay? Then the next one, -15 minus -9, that's also going to be -6. This is going to be quadratic. Okay? How about this one here? Okay? We're going here 8. Here we're going 24. Here it's not going to be linear. It's not going to be quadratic. Let's check and see if it's exponential. Okay, 12 over 4, that's 3. 36 over 12, that's 3. This is exponential. There we go. We got it. Okay, 2 pages down, 2 more to go. Okay, the owner of a framing store tracks the cost of bubble wrap for packing pictures like the one shown. How can you use the data to estimate the cost of bubble wrap for a picture with the length of 75 inches? We need to determine if it's linear, exponential, or quadratic. Okay, so we subtract the numbers. It's not consistent. We then subtract the differences, and they're pretty close. Okay, since they're pretty close, we're going to use the quadratic regression model because it's going to show it's going to be quadratic. And then once we have the equation, then we can figure out 75. So once we make the equation, we can plug in 75 after that, okay? So let's look at this here, okay? Let's check and see if it's linear first. And I think it's going to be, it might be linear. Let's check, okay? This is going to be a 10.5. Here, 10.5. Here, 10.5. So it looks like it's going to be linear. Okay, so now we can make the equation, all right? Here's your y-intercept. This is your m. Let's make it. Y equals 100 minus 10.5x. Boom, we have our equation, okay? Remember, linear equations are y equals mx plus b. For the quadratic, okay, I'll give you guys the thing to use for the quadratic. For the exponential, it's the same thing, okay? Last one, the graph shows population models for 3 cities, okay? We're trying to figure out when they're gonna be exactly the same. So we have to use a graphing calculator to determine the points of intersection, okay? Right there, and then there'll be another one right there, okay? So it looks like after so much, it looks like, you know, they'll compare with each other. So what we're gonna do is we're gonna use Desmos to graph all 3 of these to find out where they all intersect. Let's use it here real quick. I believe it's going to be this one. Am I right? I am not. I am right, actually. Boom. Okay, here we go. 3x plus 2. The next one, 2x squared plus 3. Okay, and the last one, that's going to be 2 to the power of x. Okay, so notice I zoom in, it's crossing twice actually, right here and right here for the linear. And notice how the quadratic is never going to cross, but the exponential will, I believe. Yep, that's the exponential one. The quadratic will never cross the exponential, as crazy as it sounds, but it will cross the linear one, okay, at that point there. If I keep zooming in, oh, actually it will. Keep going, keep going, keep going, boom, right there. It will cross at some point at 6.414. So we have everything there. Basically, what you're going to do for that one is you're basically going to graph all three of them. You're basically going to check to see where they all cross, okay, essentially. That's it. That's all there is to it. Definitely understand how to do this. Chapter 9 coming up. Have fun.